Hello everyone, I Yashi Bharadwaj, working as an assistant professor in the Department of Computer Science and Engineering Data Science in ABES Engineering College, Ghaziabad, is going to deliver a lecture on error in computer network. So, the content which I'm going to discuss today is error, types of error, redundancy, error control, and Hamming distance. So, these are the content which I'm going to discuss today. Okay, so now first we'll discuss error. So now the question arises is what is error? So what the statement is saying that if the data received is not same as the data sent in, this means error has occurred. So what the statement is saying that first I would like to tell you that when we are doing communication over the network, so data always transmit in the form of bits. In the form of bits means like 1010. So data transmit always in the form of bits. Okay, so this is the data which is sent by the sender, and let's suppose this is the data received by the receiver 1001. Okay, so in this you can say that this one remains same, the zero remains same, and this one become zero. Okay, so this bit has been changed and this is same. Okay, so it means that the data which is sent by the sender is not exactly the same data which is received by the receiver. So this means that error has occurred. Okay, so now we can say that in a computer network, basically data are transmitted in the network, and we all know that we are just exchanging the information. Okay, so when the data are transmitted over the network, actually we don't know that what happens to that data when it left the node. Okay, yeah, when it's already sent by the sender side, so we don't know that in actually what will happen to that data, whether it will reach to the receiver that exactly the same data which is already sent by the sender. Okay, or that data will be corrupted in middle. Okay, so data can be corrupted, we all know that, during transmission. So the error that are caused because of the transmission, we can say that this is transmission error or this is an error. Okay, so what we can say that if we want to do reliable communication, so these errors whichever is caused in between, okay, these error must be detected and corrected. Okay, so basically we have OSI model. Okay, and the question arises that, and we all know that we have total 7 layers in OSI model. We have 7 layers in OSI model. Okay, so the question arises is in which layer the error related things are handled. Okay, so actually in OSI reference model, there are 2 layers basically which deals with error control. Okay, error detection and error correction are implemented either at the data link layer, which is the second layer in OSI model, or on the transport layer, which is the 4th layer of the OSI model. Okay, so now moving forward, types of error. So basically we have 2 types of error: single bit error and burst error. So we'll discuss these types of error. Okay, now what is single bit error? So single bit error is like, the term single bit error is saying that means that only one bit of given data unit is changed from 0 to 1 or 1 to 0. As you can see this example, in this a sender send data 0, 1, 0, 0, 0, 1. But when this data received by the receiver, this 0 same and this 1 become 0. So you can see that I've already mentioned this, that this is your corrupted bit. Okay, and the 0 is same, the 0 is 0, and the 0 is 0, and this 1 is 1. So you can say that in between this 1 bit is changed, means this 1 becomes 0, or maybe 0 will become 1. Okay, so as you can see that while transmitting the data, when you send the data, when it reaches to the receiver side, this data will become this, means 1 bit is corrupted. So this type of error is known as single bit error, when only 1 bit of the given data unit is changed. So this means that this is single bit error. Now moving forward, now what is burst error? So burst error means when you are transferring the data and when it reaches to the receiver side, 2 or more bits in the given data unit is changed, then it is known as burst error. So as you can see this in this example, this 1 becomes 0, okay, and the 0 become 1, and rest of the bits are same. So you can see that 2 bits are changed. Okay, so this type of error is known as burst error. Okay, now the question arises is the chances of which error is high. Or before proceeding to that, I would like to tell you this is there is one topic. See, this was terminology which we use in this burst length. See, if I'll ask you how many bits are affected, then you will say that only 2 bits. But this is not how you will calculate this. If I'll ask you that calculate the burst length, so how you will calculate this? Let's suppose we have this data which is sent by the sender 0100 100, and let's suppose receiver receive this 0. Okay, so as you can see that this 0 become 1, so this bit is changed, this 1 becomes 0, this bit is changed, this is also changed. Let's suppose I'm doing this 0 and this is same and this is also changed. Okay, so if I'll write the position 1 2 3 4 5 6 7, so you will not say that the 4 bits are changed, like 1 2 3 4. No, you have to count that. Now see, you cannot say that 4 bits are changed. When we calculate the length of the corrupted bit, we cannot say that it is 1 bits are changed, 2 bits are changed, 3 bits are changed, 4 bits are changed. Basically in this the length of the burst error is 6 bit. Why? Because जो हमारा डेटा अफेक्ट हुआ है वो यहाँ से लेके आपका यहाँ तक हुआ है, like 1 to 6 हुआ है, so we can say that 6 bits are changed. So because this is what the entire length of the corrupted bit. So this is how you will calculate the burst length. Okay, so now moving forward, now the question arises is what type of error chances is high, like chances of which error is high, burst error or single bit error. Okay, now I'll explain you with this with a simple example. Okay, see, let's suppose we have a, in the question, let's suppose this is given like data rate, we all know that we have already discussed in the previous lecture what is delays, types of delays, bandwidth, velocity, packet size, speed. We have already solved all these kind of questions. Okay, so data rate is nothing but a bandwidth. So let's suppose in question bandwidth is given 1 kbps. Okay, and while transferring the data, suppose noise has occurred. Okay, so let's suppose noise is also given. Let's suppose noise duration is 1 upon 10 seconds. Okay, this is the noise duration. So what we have to find out, we have to find like number of corrupted bit. So if I'll ask you that find the, sorry, number of corrupted bit. So the formula for calculating the number of corrupted bit is basically that data rate multiply by noise duration. We can say that. So first we'll convert it into bits per second. Okay, so the question is asking that how many bits are corrupted while transferring the data. Okay, so first we'll convert it into bits per second, and we all know that 1k is equals to 10 to the power 3. We are converting it into bits per second. Okay, so this will become 10 to the power 3 bits per second. Okay, so just do the simple maths. 10 to the power. Okay, so this will cancel and this 0 will be cancelled. It means that 100 bits are changed. So we can say that chances of burst error is high as compared to single bit error. Means if only 1 upon 10 second duration, मतलब इतने कम टाइम के लिए अगर हमारे डेटा में नॉइस आ जाता है, तो इट मीन्स दैट और 0.1 सेकेंड के लिए भी अगर आता है तो आपका 100 बिट्स अफेक्ट हो रहा है. Okay, so the chances of burst error is high. Okay, so now moving forward, what is redundancy? So redundancy, basically we use this concept in detecting and correcting error. So we'll discuss this also, like how to detect the error, how to correct the error. Okay, So when we are transferring the data, we need to send some extra bits. Okay, we need to send some extra bits with our data to detect and correct the error. So basically, these redundant bits can be added by the sender and removed by the receiver. See, we'll discuss this also, but I'll quote a simple example. Let's suppose I'm transferring the data 001. Okay, this is 1. Okay, so and and while sending the data, I'll append one extra bit. This extra bit could be 0 and this extra bit could be 1. Okay, so this will be added by the sender, and when the receiver will receive this data, so this bit will be removed by the receiver. So what is this is saying is, we need to send some extra bit with our data to detect and correct the error. So when we are transferring the data over the network, we'll send some extra bits while transferring the data. Okay, so we'll discuss this in detail. So before understanding this, I would like to tell you that error control. Okay, so we all know that error control is a responsibility of data link layer, which is the second layer in OSI model. So basically, we have two error control methods. First is error detection and second is error correction. Okay, so basically, error detection is also further divided how we can detect the error. So there are also some methods for detecting the error. So first one is simple parity check, and second is 2D parity check, third one is checksum, and fourth one is CRC. So we'll discuss these in details in the further lectures or upcoming videos. Okay, so and error correction can be done with the help of the Hamming code. Okay, so these are basically error control methods. Okay, so now moving forward. So before proceeding to these topics, first we need to understand what is Hamming distance and what is minimum Hamming distance. Okay, so what is this like? Hamming distance means Hamming distance between two binary string of same size is the number of differences between corresponding bits. See, I'll quote an example for you. What is Hamming distance? See, this is x comma y. Okay, let's suppose sender sends the data 1010. Okay, and receiver receives the data 1110. Okay, so as you can see that while sending the data, see, you can write it like this also: 1010 1110. So this is your sender and this is your receiver. Okay, so as you can see that, so how many bits are changed? This one remains same, and the zero become 1, and we can say that only one bit is changed. Okay, so Hamming distance will become 1. So the statement is saying that Hamming distance between two binary string of the same size is the number of differences between corresponding bits. Means receiver received the exactly same data which is already sent by the sender, or bits have changed or not. So this is basically a Hamming distance. Or we can understand this with one more example. Let's suppose receiver sends the data. Sorry, receiver receives the data 1110 and sender sends the data 0001. So as we can see that 3 bits are changed. So we can say that Hamming distance is 1. Sorry, 3. Hamming distance is 3. So this is your Hamming distance. Okay. So now moving forward, minimum Hamming distance. So minimum Hamming distance means minimum Hamming distance is the smallest Hamming distance between all possible pair of code word. Let's suppose we'll understand this with an example. Let's suppose we have this 011 and 001. We'll take very simple example. Okay, so what we'll do that, we'll put here, suppose this is A and this is B. Okay, okay, so I'm adding one more, 1101, and suppose this is C. Okay, so this is basically your code word. This is your valid code word or data. We can say that this code word is nothing but a data. Okay, so what we are doing is, let's suppose we are making the pair. Okay, so कितने pair बनेंगे हमारे इसमें? One pair will become A comma B, and one pair will become A comma C, and one pair will become B comma C. Okay, A comma B, A comma C, and B comma C we have already made. Okay, so in total 3 pairs will be made. Okay, so what we have to do, we have to calculate the Hamming distance, and we have to calculate among three minimum Hamming distance. Okay, so as you can see that in A or B, the zeros become zero only. Okay, and this one becomes zero. Okay, the total Hamming distance is one. Only one bit is changed, so Hamming distance will become one. Now we'll check for A and C. See, I'll write here. A is 011 and C is 101. So as you can see that two bits are changed. So Hamming distance is 2, means two bits are changed. So Hamming distance is 2. Now we'll check for B and C. So if you will see for B, the value for B is 001 and for C is 101. So you can see that this bit changed and remaining two bits are same. So Hamming distance of B and C is 1. Okay. So the question is minimum Hamming distance you have to find among all these pairs. So minimum Hamming distance is 1. Okay. So this is how you will solve such type of questions. Okay. So today we have discussed error, single bit error, burst error, redundancy, and error control methods, and Hamming distance, minimum Hamming distance, and how to find out the Hamming distance or minimum Hamming distance. Okay, so these are the references which I have used, and we'll try to cover more topics of computer network in the upcoming lectures. So thank you for my side.